scan this guy, and then do like one quick like thing. Oh. Okay, a couple of things I'll just like preface this with is that all the slides are built in last minute in Formidable Labs. They posted this thing on Twitter where you can write all your slides in JSX. So like I wrote a presentation in React. You should check it out. It was super cool. But if anything breaks, tweet at them. A lot of my research came from the React library and basically just like some spacey ES6 Hello World React and React to do. And it's also React 13.2. So there's a lot of stuff that changed in 14. So pretty much all of this could be a lie. And what we're going to do is I'm going to get kind of super low level for a bit. So if I disregard questions or talk kind of fast, it's because there's like a lot of like low level content that I just want you guys to see. So what we'll talk about is the virtual DOM, basically how React implements its flavor of virtual DOM, and that's what this talk is about. Let's see. So one thing we want to talk about or note is React's got about 154 models inside of it, all of which makes React function. We're only going to cover sort of 30. So like we're like as low level as it gets. There's a lot going on. It's like 20,000 lines of code, so there's a lot going on that we're just not going to touch on. Yeah, that's at 154. So there's four phases that I kind of want to touch on. The first is going to be called mounting. You'll know it as your main React.render. Give it your root component, give it the container, and let it do its thing. We're going to call that mounting. We will talk about setting up state and what that does in terms of the VDOM. We're going to talk about props for a little bit, like super high level, and then we're going to talk about performance. So most of you guys, and the Zoom is like super low, but most of you guys know this like super simple code, right? You talk to this exposed React interface, you give it the render method, you say, here's the component markup that I want you to start with, and here's the container that I want you to inject that into inside of the DOM. And that's pretty much your entry point to React, and you let it take over from there. So let's talk about how mounting actually works. Everything kind of centers around this main class in there called React Composite Component. And React Composite Component actually gets exposed inside of React and used inside of React as this React Composite Component wrapper, which is a named function inside of the, I'll just say, instantiate module. So there's a named function instantiate module that's called Composite Component Wrapper, and you inject a composite component into there. So that hello world component we just saw is going to be referenced as composite component wrapper, but it's really just composite component. And there's a couple of properties to keep in mind off the top of that. One is the private instance, which is really what gets exposed back out through React.render. And then there's also the render component where it keeps what's the most recent state of rendering. And then there's this React class, which you build when you say all of your components that you build, you say React.createClass, right? That's the class that you're exposing. Like you're telling it, inject this stuff, give me back this React create class. And React component, which is basically just a fairly super low level, super light module that puts like set state and force update on the root. Which actually leads me to another thing. Like they make heavy use of mixins. So part of the reason why there's a ton of models is that some of them are super light, and they basically just throw things on the prototype, and then they just do a bunch of mix-ins to compose this one big thing. And that's part of the reason why there's so many models. But remember this because this is essentially what we're working with. So this is literally me just dumping out from DevTools, right? So once the hello world process, once we injected that, all the magic that we're going to talk about comes back. This is literally it. I mean, you dump it in DevTools, and like this is what gets instantiated. There's a whole ton of stuff on top of it. But the main thing is, you see it's a composite component wrapper. The React IDs that you see all over the place, they're literally just like, they look like a really, really super long symbar tag. And so our root component is .0. And then as you start building this syntax, this tree, you'll get like a .0, .1, .2, .3. And then .1 will be .1, .2, .3. And also the main thing here is this render component that we talked about. It's got a self-reference to, it's got the underscore instance underscore render component. This is your React root object that gets created. It's, like we said, it's a self-referenced object, so the zoom is like really, really bad on this. But this is the render component. You see, it's got like the main thing here is like render children, right? There's .0, .1, .2. You can see where the tags start coming in and all this good stuff. But like this is it. Like there's nothing. It's nothing too crazy, but it is at the same point in time. There's a lot of things on top of it that you really don't know what's going on. So that was really just an aside. So that's like what we're working with in terms of like just React objects. But when we talk about how it's actually implemented, like everybody knows this exposed React interface, React.render, right? So React is just one of those 154 modules, and you interface with that. But React.render is actually just an alias to this other module called React Mount that also exposes a render method. It's just a glorified pass-through. And once you come through that exposed React interface and now are into React Mount, you're going to hit that public render method that actually just forwards on to a private underscore render new root component method. And that's like, this is the sauce of mounting. So like it's orchestrating all of the things that we're going to talk about that need to happen. So it's literally just the logic for mounting. And it's pretty big. And the method's not super huge, but like the things that it causes to happen are get pretty deep. And once you're inside of this render new root component, then this is where we talked about this instantiate React component module. The first thing it tries to do is instantiate a React component. And it's just an exposed function module. You call the function, that's all it is. And what it does is gives you back a newly created function, React composite component wrapper. So it just returns you this composite component wrapper object that you start to work with. It's just a shell of one. So that's step one, is just creating this empty composite component wrapper. Now, once we've created that guy, what we then try to do inside of React Mount is we're going to register both the component we just created and we're going to register the container that we just created. So React Mount actually maintains two arrays, well technically three, but two arrays. One where it takes the root instance that we created and does an array.push on that. And then it also takes the container that we said, hashtag container, whatever you want to call it, and injects that into an array. And that's all. That's what we do when we want to register these components. So creating the VDOM is just array.push. Then once we've registered our component, our container, then we get into this kind of batching process they call batching. And so we have this module exposed called React Updates that exposes a batch updates method. Once we hit inside of there, it's actually going to do two checks. Like it's going to first see if am I batching? And if I'm not batching, then what it's going to do is start that batch. And then what it does is the way that methods get invoked in React is this transaction magic, this module, and it's magic because what you're basically doing is passing in callbacks that you want the perform method to actually just execute for you. But what they do is it's this, it's their way of logically doing a transaction where I've got some pre-function things that I want to get done, and I've got some post-function things that I want to get done. And you don't actually tell it the pre and the post, it's the things that React wants to make sure that gets done. So there's initialize methods that get attached, and there's close methods that get attached, and they're just additional callbacks. and it's magic. You don't actually like tell it what to do or anything like that. It just, this is how they do it. And it also tries to do error catching. So like, I don't know if any of you guys ever worked with, like, say, Koa as a middleware router, but like Koa does this thing too, where it like defaults to an error status, and you have to provide successful functions for it to override. And transaction does the same thing. They set some error state to true, and then you have to, you don't really have to ensure, but like your code as it traverses the React things need to not throw errors, and then it will set the error state to not be an error. So the first part of batching is in Perform is you're going to call back to React mount this batch mount component into it, and all that does is just literally immediately tells transaction, oh, by the way, I want you to perform a mount component into node method, and what it does is just forwards on to this class React reconciler mount component. And this will be kind of a recurring theme that you'll see, like a chain of functions all called the same, bouncing around between classes as like public exposed mix in to a public exposed that wraps the private exposed. So as I kind of step through these things, it's mostly because they're literally just forwarding on the chain, doing something very minor that we're not really interested in right now. So like we talked about, the first time batch is literally just a semaphore lock. So inside of React mount, like, am I batching is, if it's false, continue, by the way, set it to true. And that's, then the second time, if you come to a second time batch, it's like literally just perform these methods with transaction. So now that we've gotten kind of into the batch, like we've started a semaphore lock and we're in a batching process, we're going to come into that mount component, and this mount component got actually added onto your React composite component wrapper. And this is where we're going to do things like component did mount, right? So you'll notice some of these like lifecycle hooks that get exposed that we all know about, like will receive props, did mount, should update, all these things. And its entire intended purpose of doing like component did mount to the render and then ultimately back to the component, or sorry, will mount all the way back through the rendering process and component did mount, its entire purpose is just render HTML and register events. So this is where that magic kind of happens. And let me go make sure, yeah. So the magical part here is in render validated component. And that's like super deep. You could actually literally just spawn another process off, or another talk off, because this is where we actually say like the hello world component that we exposed, call its render method, and then start traversing that component tree, and then going back to the same process again, so that we can call the render methods on the child components to get this object that we built, and then take that object and get the markup and make sure we inject things like the React IDs that you see on all of the elements when you get all of it exposed. So this is where all of that magic is happening. At the end of this process, we will have the HTML string that we're going to actually inject. And at the end of that, we call back into React mount, mount image in a node, which you saw on like a previous slide, right? And literally it just does a node.insert for HTML. And that's it. So we did all that work and then literally just inject right into the DOM. So this is actually a really simple step. The markup generation is really, really where all like this like crazy traversal magic happens through all the different render methods. And what it's doing is trying to build, remember we saw that React composite component wrapper object, it's building all that, injecting children, adding event listeners, and all of that. That's a super, super low, and I thought that would be like way too boring for me to like go through all of that, just recursive logic. But it's basically just going through the render process again. So that's, at this point, like we've mounted a node. Like once that set inner HTML is done and traverses back up the tree, you know, just the callback's just coming back, we're done. We have our page. So that's the mount, like that's the initial mount. There's some magical things that kind of happen that we talked about with transaction in that I think we'll talk on in set state. But things happen like as part of the callbacks that start this new chain that you have like really no idea how it happens unless you actually go like step into in the dev tools. So now we've mounted and we have UI. So what about set state? When you call set state, you're calling set state that we talked about was on the React component. So you call into that, and you're giving it like the new state objects. And it's going to try to in-queue the set state, or put it in the queue, through this exposed module React update queue, which just forwards on to this in-queue update on the React updates module that we've already kind of covered. And once we've gotten that in the queue, similar to like what we did with registering components on the initial mount, this is kind of like you're just registering the state change. And now what we want to do is we want to do this batched updates method again, and exposed on the React updates module. Literally calls through to a mix-in method that just forwards on this batch updates of the React default batching strategy, which is a really long-winded way of just saying like the batching process of like blocking and then starting again. And then it forwards on to the transaction perform again, the same guy that just does an in-queue update method that's exposed on the React updates. Now that then takes the component that has changed and just does an array dot push into this array called dirty components. And that's literally all the batching process is in set state. It's just an array dot push onto dirty. So we've got our batch update in. And this is kind of the magic that we talked about, where with the transaction you can kind of get into, is that transaction is going to invoke this perform method from in-queue update to say, okay, now run this run batch updates. And what we get into in the next slides will be called from there. But I wanted to point out that like this is the magic part where this like flushed batch updates method, it gets called as part of those initialize and close functions that got injected onto your transaction. So you don't actually like specifically tell it. Like you can go all the way through the chain and like think, oh, I'm done. What happened? But if you set breakpoints on these like flush batch updates, you find out that like the transaction module itself invoked them for you. So this batching updates is going to call React reconciler again dot perform update if necessary. So React's going to start with a pre-check to say perform update if necessary, but that's just a flow through to perform update if necessary on composite component again, and we'll start with it looks and checks for mutated props. So that's not like a diff on the props. It is a diff, but it's not looking for like did the values change. It's literally looking for take the keys on props and see if the key's been removed or if a key has been added. And if that's the case, then like React is actually going to try and do a force update for you. So then if it once it gets back for the check for mutated props, then it's going to call this update component method on React composite component. And update component is pretty thorough, like the updating process. But the main thing is like you'll recognize again this lifecycle hook of should component update that's exposed on side of the component that we created through the RCCW. I'll just start saying that for short. I'm sure you guys are tired of hearing me say composite component all the time. The next slide gets deeper into actually like performing the update. So we checked and did like an is update required, right? So we checked for mutated props, we called the should component update, and at this point React feels pretty confident that like an update needs to happen, and it's going to try and call perform component update. This is where it will call your component will update lifecycle look, and then it's going to forward on to update render component. There's a lot going on there. I think that means I told myself I'd dedicate another slide to it. When this update render component method that we're going to get into comes back, it just calls component did update, and then boom, you're back in the stack. This is where we talk about like update render component. It starts out with like getting these validated child contexts. Honestly, I couldn't find a case where I could like make that do anything yet. So I want to do more research on what this child context methods are doing. But it calls this, you see again, it's our old friend, this render validated component. But before it does that, it actually does another check, like should update React component, and tries to check for some more like, hey, at this point, have props been mutated to like a plugin, or is there like some other lifecycle thing going on inside of React that has triggered some like pending state, and I need to check again to see if I really should update this. And once it gets back from that, it will actually try to render it again. Do this render validated component, and then you're going to try to make it receive the component and update it again. Sorry, I'm going a little faster because I'm on time, but ultimately we get down to this React DOM component we call update component. Again, update DOM children, things to do with the children. I think that's probably partially too with the like small apps that I was testing on. There not being like specific child cases where it'll actually trigger like some sort of child like reflow. But then ultimately update component happens and you just call this private method called update DOM properties. This is where it just goes to the props and see if they require DOM updates. So, yes. One thing to note here is like, I had a really hard time finding a case where, at least from the way I was thinking about React, of, oh, it's traversing the DOM tree and seeing if things have changed. It doesn't actually appear to be doing things like, I'm going to look at the style of your button and see if it changes. No, it's actually just, it's diffing the VDOM. So if you can actually underlyingly change the DOM, and like it's not checking on those things. So that's one of the like gotchas that like didn't really set it until I started moving through all this stuff. And that's why you get so many warnings about, hey, you didn't notify React, like please notify React, use the React lifecycles. Otherwise things in the DOM just kind of get lost and will get like replaced over. Like using jQuery wrappers inside of your component, it'll just get overridden. We lightly talk on props because one of the major questions is like, are props changes automatic? And what I've been able to find so far with prop changes are that certain elements, like all of your divs and forms and inputs and text boxes, they ultimately get converted into React DOM input, React DOM select, React DOM text area, React DOM form. And in some cases, React actually injects these handle change on change methods to some of these. So these main three, the React DOM input, select, and text area, like it actually will inject props onto that and see if it's changed or not, and add an event listener for on change. And it tries to do this ASAP enqueuing, which basically means like force update this irrespective of a matching process. With this like callback queue, which is kind of like magical, that I didn't get a chance to fully dive into. So sometimes prop changes are automatic, I think. Then we want to talk about the last thing is there a performance impact? And I think the answer is yes. Forgot. So this is kind of like a Q&A moment. Like, did I not touch on something that you guys would like to talk about before we talk about like things you can do to improve like performance at all? No, I know, because I've been talking like for a really long time. Nobody's. So 3 of the main improvements you can do for perf, and most of the stuff I think most people already know. It's like use keys. React will warn you if you don't use keys, but this is how it tries to say I already know about this element before, so please inject a key onto it so that I can maintain that key and know whether I've rendered it. You can use should component update, and you probably should use component update. You probably should use should component update a lot. And one of the other things that we just talked about, had a conversation on the other day, is there's this big thing of passing a lot of your styles in via prompts. But if you think about it, I'm checking this render method, anytime any single thing happens, I click a button, I do this, that triggers the whole re-render cycle. So if I'm passing all these styles in via props, and that's adding to all of the things I need to diff. So if you are injecting dynamic styles of things that actually do change based on some sort of state, then by all means do what you have to do. But inline styles that are static, I want this button to be 100 pixels, it's probably best not to do it if it's not going to change, right? So those are 3 major ways that you can do on improvements, is just do things to kind of appease React. And obviously one of the trade-offs of that is that you are, to achieve performance based on the type of app you're working on, you are going to have to do some stuff to appease React. You're going to have to do should component updates. You're going to have to think about props, whether this impacts the rendering cycle. You need to think about appeasing React via the number of components. So we talked about how React is not comparing your DOM and saying this is different. What it's doing is comparing your components. So if you make these super large components, it's gonna re-inject an entire gigantic piece of DOM in there. And talk about how actually that's not that bad, but you do need to create a lot more components with smaller markup so that you make that tree a little bigger. It's okay to have a big tree in this case, because what that means is if I have a major component with 2 major sections of a page, right? Well, if only one of those changes, then half of my tree is not getting re-rendered, which is good. And then you can use should component updates to force it down a traversal path of not killing everything and just reinserting it. But the trade-off to that is now you're doing things I don't want my add new something button to get re-injected every single time, so I'm wrapping it in a React component button, or I'm wrapping a search bar. Search bar is really bad, but the header on a results list, I'm wrapping that in a component so it doesn't get re-rendered in the DOM, because it doesn't need to change. So you have to think about these type of things right now while React is evolving with the performance issues. I shouldn't say issues. It's what people are trying to do with apps that can cause performance issues. Displaying a list of 10, you're never going to notice it. Displaying a list of 1,500, as a lot of these perf tests like to show, that's when you will start to notice it. And actually, last week while I was working on this, like a gift from God, Eric Twist blogged about the perf, and that one of the guys from Google did a thing on here to try and simulate what you would get from Flickr or Airbnb, where you get a photo back and some sort of content. And it was, I haven't had a chance to really, really deep dive into the way what his test was doing and how he's measuring performance and stuff like that. But some of his numbers were pretty high as you start to do things like having a bunch of photos and a bunch of headers and stuff like that, and if you're not using keys and you're not adding components to make sure that you don't re-render a bunch of stuff, the performance can get really bad. And especially if you're mobile first, you're going to drain battery, basically. And that link is here. If you want to look at it, it's actually this guy right here. So I would encourage you guys to all go read this if you haven't already. I think most people are really good about looking at things on Twitter and seeing things come out. But this is actually really, I think it's a really, really good article. He did a really good job on trying to talk about what he was doing, photos with some headers. And then one of the things I find interesting is that he actually tries to do a really good job of like the DOM update time, and the DOM update time actually like stays fairly consistent when your app is like when you're building a page and like most of the components are the same. So you actually can get a really good projection of what time it's taken in the DOM, and at least in his test cases, I think they were like pretty floating around like somewhere around 10 milliseconds, and like the amount of time that React and the JavaScript was taking to run was just ridiculously exponentially higher in some of these cases. And like I said, I haven't had a chance to deep dive into his test and recreate it, but it's really shown a good job of like if you're not using show component updates, if you're not using keys, that it can impact performance. But honestly, I think that's also part of what you understand in that React is huge. So it does things for you to help you out, but they come with trade-offs. So this is what I think is a really good follow-up for anybody who wants to read. It's just arrow twist. Just search for like React performance. So that is the end of my slides, I believe. So I'll get back to where I was. Yeah. So that's the end of my slides. So yeah, that's the React VDOM minus some magic for diffing and recursively reversing renders. Honestly, I think those in and of themselves would be like entire talks because they're really, really spacey. Any questions? Q&A time. Ideally, I'd like to talk about things like anything actually. So, any questions or anything to talk about?
In your investigation, have you seen whether more frameworks would adopt VDOM as a performance improvement for their own? Do you see that spreading as a general theme? Yeah, I mean there's a couple of libraries that are spouting up that are calling themselves like reactive, right? Riot.js is one you can go look at. Don't use the code; they don't use semicolons. I'm just kidding. This is recording. But there's a lot of room for interpretation, right? Because React is like 20,000 lines, but the Riot library that Ricky sent me is like 1,200. So there's different ways to do it, and part of the way is just like how you accomplish just writing components. Because the Riot library is you just write your HTML with an inline script tag, and then you put that above your style sheet, right? So it then says, okay, just that's your component. It's very Polymer-like. It feels very Polymer-like. There's on GitHub. There's literally a guy just wrote a virtual DOM implementation. Part of the thing with these libraries, and part of the thing with like the way React handles event listeners differently, it takes all of the event listeners and attaches them to the root, and then lets them bubble up, right? And then so other libraries are probably going to make trade-offs to that and say like, actually, I'd rather attach the event listeners right to the DOM mode that they're on, because the React justification that I think I saw was that attaching a bunch of event listeners is like to different DOM elements is really heavy, so we attach it to the root. But at the same point in time, and I haven't seen a perf for this, what's the trade-off of letting those events bubble all the way up if you've got a really deep tree that you're also writing to appease other areas of performance? So I think some reactive libraries that might come out of this are how can we take like HTML as our components and then render that into a true like VDOM. Like it's not like a made up thing inside of React or inside of like Cycle or something like that. It's the actual DOM that you know and love, but you're truly diffing like the VDOM to the DOM. And then that way it's like a little closer to home, so you don't have to add a lot of abstractions over the top of that kind of weigh down the JavaScript, like cycling through and attaching just like raw event listeners to your VDOM, and then just like literally just reinjecting that markup. Because that's the trade-off, right? Is that writing the VDOM stuff as a large component, all of the performance checks that are going on, I mean, they have to be more performant than literally just taking DOM markup and just re-injecting it and letting the browser handle it. I think that's like really slow it can be really slow when you inject like huge chunks of markup, and then you have to like reattach event listeners, clean up event listeners, old ones, and stuff like that. But for the most people, when you're building like simple apps, these smaller libraries like Riot might actually be a better way to go, just because you're like overhead of knowing React probably way down. I think it'll evolve. They'll find ways to like. There's like certain classes inside of the React library that ultimately I think as they try to get more performance out of it, they'll go away. There's like a exposed module called React Instance Map, and anybody who works in social tables has heard me complain that it's like this abstracted getter setter, but you have to pass the object in and the key that you want it to set or get, as opposed to literally just referencing the object itself. So that's one extra hop and back inside of the cycle that you could probably avoid by just referencing the object. So I think it might end up being where React slims down over time and then is closer to more like embedded or ops system code, where you're not necessarily worried about all the layers of abstraction. You really are trying to like squeeze out performance, but still maintain that JSX style syntax. So yeah, I think there's a lot of room for interpretation of like what it means to be a VDOM and what you have to do to implement that.
What was your favorite module in the React?
I'd say my favorite module, yeah, it's probably that React Instance Map, because I'm not quite sure why it exists. Like that might actually be another way to talk. I'll present why, like a justification for why it exists. Because those type of abstractions are literally just like, okay, I'm giving you the keys. I'm giving you an object, and I want the key back, but the key is literally already on the object. So you'd be better off just to reference the object there. So there's some things inside of the React library that are abstractions, I think, just for the sake of abstractions that you probably don't need. But that's more of a reaction than a response, because I haven't dug deep enough. The render validated one is good too, because I spent 2 hours doing step into it, still couldn't get to the end of the chain where I could like start to look at that. So.
Cool. Thank you.